In this video, let's take a look at how you can create your own dedicated compute and deploy your models to it. First, let's go to the compute section, and from here click on create a new cluster. Here provide the cluster ID. Let's name it test cluster. You can give some description if you need, and choose the cluster type. You can just go with the dedicated Clarifai cloud compute. We will also be soon launching self-managed compute where you can bring your own existing compute resources either from the cloud or on-premise instances. You can now select your preferred cloud provider and the region to deploy your models. We currently support AWS, GCP, Vultr, and Oracle. Soon we will be launching the support for more cloud providers. Let's go with AWS and US East. Also select a personal access token. This will help verify your identity when connecting to the cluster. So if you already have a personal access token, you can just go with the one that you already have, or you can create a new one from here. Let's go with this personal access token. Next, click continue. Now specify the configurations for your node pool. Provide a node pool ID. Let's give it as test node pool, and you can just give the description as well. Next, specify the node autoscaling range, which defines the minimum and maximum number of nodes the system can scale automatically within the pool based on the workload demand. This means that the system will spin up more nodes to handle increased traffic or scale down when demand decreases to optimize your cost. For instance, you can set your node pool to scale between 1 and 5 nodes. Maybe I can just set it as minimum instance as 1 and maximum as 5. Now, depending how many requests your model is processing, a minimum value of 1 rather than 0 prevents cold start delays after inactivity, which is essential for meeting latency requirements, though it ensures that one node will always be running, which results in compute costs. Alternatively, you can set a minimum instance to 0, which eliminates the cost during the ideal periods, but this will introduce cold start delays when traffic resumes. So you can just configure this based on your use case. But let's set the minimum as 1 and maximum as 5. Next, select the instance type on which you would like the deployment to run. These are all the different AWS instance types available, designed to handle variety of ML workloads. These instances, if you just see, they all vary in their CPU, RAM, and GPU configurations, which allow you to orchestrate the right balance of performance and cost based on your use case. There are T3A, G4DN series, G5, and G6 series. The T3A series is ideal for cost-effective general-purpose workloads that do not require GPU acceleration. Similarly, if you just check the high-end G6 series, this is ideal for most demanding machine learning workloads. You can explore all these different instances based on the model you are trying to deploy. In this example, we will just try to deploy the Llama 3.2 model, which is available on the community, which at least requires NVIDIA A10G with 16 gigabytes of CPU memory. So we will go with the G5 2 extra large. It just provides one NVIDIA A10 GPU, and also it just provides the required CPU configuration, which is ideal for the model that we are just deploying. So let's select that. Additionally, you can leverage spot instances to rent spare unused compute at significantly lower prices compared to regular on-demand instances. But keep in mind that if no spot instances are available, Clarifai will automatically fall back to your on-demand instances. So even though if you select the spot instances, note that spot instances can be terminated if capacity is needed elsewhere, temporarily making your node unavailable. So it's recommended to use spot instances for not so critical tasks. Finally, let's create the cluster. I can see the cluster has been created and the node pool also has been created. You can also create multiple node pools within the same cluster. You can just click on create a node pool from here, and you can just define another node pool with a different instance type and different node autoscale settings. Now let's try deploying a model to this cluster. You can also upload your own models to the platform and deploy them to your dedicated compute. We will cover how to upload your own models using the Python SDK in another video. For now, let's use one of the existing community models and deploy it to this cluster that we have created. I'm clicking on deploy a model, and here let's provide the deployment ID. I'm going to go with test deploy. Now let's select the model. I'm going to go with the Llama 3.2 3B instruct model, which is available in the community. I can see this is the model. And also select the model version. I've just selected that. So once you select the model and the model version, now let's select the cluster and node pool. You can see the cluster has been selected, the test cluster that we have created, and the node pool. This is the node pool that we have created, the test node pool. Select that. Also now within the advanced setting, there are several options that you can configure. The first one is the model replica range. So this defines how many copies of your model can be running at the same time. Minimum replicas is the smallest number of model instances that will always be running. Maximum replicas is the maximum number the system is allowed to spin during the high demand. Let's set the minimum model replicas to 1 and the maximum replicas to 3. So you might think like why this is matter. More replicas allow your model to handle more user requests simultaneously, improving your performance and reliability. But at the same time, running more replicas also means it uses more resources like CPU and GPU, which can increase your cost. You should set this range based on how much traffic you can expect and how responsive your model needs to be. So based on that, you can configure both the minimum and maximum replicas. We have just gone with 1 and 3. Next is the scale up delay. This is the number of seconds the system waits after detecting an increased traffic before adding more model replicas. So why this is matter? Like sometimes the traffic spikes are short-lived. This delay prevents unnecessary scaling when traffic briefly increases. It helps avoid spinning up resources too quickly and wasting your compute. So it just waits for a brief time and then scale up the resources. Similarly, scale down delay. This is the number of seconds the system waits after detecting a drop in traffic before removing the replicas. Next is the traffic history time frame. The system needs some context to decide whether to scale or not. A longer time frame smooths out short-term fluctuations and leads to more stable scaling decisions. So this sets how far back the system should look at your traffic data when making decisions about scaling. So that's this traffic history time frame. Even this is by default 300 seconds. Next is the scale to zero delay. If your model hasn't received any requests for a while, there is no need to keep it running and consuming resources. This setting ensures that idle models automatically shut down to save cost and can spin back up when needed. This is the amount of idle time before all model replicas are shut down completely, like scaling down to 0. And similarly, this disable node pool packaging. By default, the system tries to pack multiple replicas onto each node to make most of the available resources. But if you enable this setting, each node will only host one replica, even if there is an extra room, right? Disabling packaging can be useful if you want to isolate replicas for better performance or debugging, but it leads to underused hardware and higher costs. So you can just enable this based on your use case. After you configure the advanced settings, let's try to deploy the model. I'm just clicking on deploy model. You can just notice the deployment has been created successfully. It may take a few minutes to deploy depending on the model and also the instance that you have chosen. I will wait for a bit and come back once it's ready. Alright, the model is now deployed to the cluster. Let's go ahead and test it. I'm clicking on this model link. You can notice by default, the deployment that we have created has been selected, the test deploy. Now let's try to pass in a prompt and interact with this model. Hi, who are you? I'm just giving some prompt to just see, and you can see, hello, I'm an assistant designed to provide information. Cool. What are the top 5 sports? Generate. You can also see the model response is so quick since we have just deployed it in our own dedicated compute, and also we have set that minimum nodes to 1 and also minimum model replicas to 1, so that we won't even have cold start delays. You can also notice how fast the response is. Let's give another prompt. What are AI agents? Generate. You can see the response here. So yeah, that's how you can create your own dedicated compute and deploy a model to it. You can also follow the same approach to deploy your own models that you have uploaded to the platform, or any of the models available in the community as well. We have just seen how to deploy Llama 3.2, but you can follow the same approach if you want to deploy DeepSeek, if you want to deploy Gemma or any other models. You can just follow the same approach. That's it for this video. See you in the next one, and thanks for watching.